Hello everyone, in this video we're going to talk about water properties. Make sure you have your Biochemistry 2 notes that you picked up from class so that you can take notes while watching this video. Before we can get started on talking about water properties, we have to take a look at the periodic table. So when you look at the periodic table, the hydrogen is located on the left side of the periodic table and oxygen is located on the right side of the periodic table. Today during class you'll learn about the trends of electronegativity when you're looking at a periodic table. When you're going from the left side of the periodic table to the right side of the periodic table, the electronegativity increases, right? So when you're comparing the electronegativity or the affinity of an atom to its electrons, it's higher, the electronegativity is higher for oxygen than it is for hydrogen. So the result is when hydrogen and oxygen are bonded together, oxygen will pull the electrons closer to itself. The hydrogen never loses its electrons, so we're still having a sharing of electron situation, which creates a covalent bond. But in this case, because it's an unequal share of an electron, oxygen will have a partial negative charge and hydrogen will have a partial positive charge, and we have what we call a polar covalent bond, and we say water is polar. Okay, so once you know the property of oxygen itself and the hydrogen itself, we can move on to talk about water properties. So again, on this page it tells you again that water has hydrogen and oxygen, and you can see oxygen is really trying to pull on the electrons from the hydrogen, and that water itself is called an inorganic molecule because it doesn't have carbons in them. Okay, so once you're done taking notes, we're going to go on to the next page. So the next page tells you about water properties. Like we said, water is polar. Whether water is wet or not, we don't really care, but water is polar. That is definite, okay? Water is polar, again, because oxygen pulls on the hydrogen, pulls on the electrons more than the hydrogen would, and the electrons are shifted towards the oxygen atom. So water is a polar molecule. This means that it has a partial positive and a partial negative end. Again, hydrogen will always have a partial positive because it's not very electronegative, and oxygen will always have a partial negative when it's bonded to hydrogen because it's so electronegative, okay? Remember the dog fights? This will be the big dog, and the hydrogen will be the little dog. Next, because water is polar, it's also a really good solvent. So how it works is that water having those partial positive and partial negative ends allows it to interact with other molecules and dissolve them and pull them apart, okay? So what you see right here, salt is NaCl. Salt is an ionic molecule, which means the sodium will have a full positive charge and the chlorine will have a full negative charge. This allows water to interact with it. What you see right here is that these partial positive charges on the hydrogen allows water to surround the chlorine in such orientation. The positive and the negative are attracting to each other. And the same idea, but the opposite. Sodium has a positive charge and the oxygen has a partial negative charge. This allows oxygen to attract to, well, the oxygen, the partial negative, to attract to the positive sodium. And this allows chlorine and chloride and sodium ion to be pulled away, okay? In order for something to be dissolved, the molecules have to be pulled away. And water, or any molecule, is always moving. So as these water molecules are moving around, it's going to be able to separate sodium and chloride completely. They're no longer together. And this allows water to dissolve something. And then when you think about water and oil, for example, oil is nonpolar, which means it doesn't have any charge at all. It's impossible for water to dissolve oil because it doesn't have anywhere to interact. There's no attraction between water molecules and oil. So here's what you need to know. Because water is polar, okay, it's all about the properties of water right here. Water is polar, so it can dissolve almost anything, or at least anything that is also polar or that is ionic. So we give water this nickname called the universal solvent, being dissolved in water. So you can take a look at this. You can see it.
Sodium chloride is placed in water.
Right here.
Water molecules interact with the ions on the surface.
See? There's this interaction between...
Salt is soluble The attractive interactions with water molecules overcome the ionic attractions within the lattice.
See, water is coming in and dragging away the sodium and the chloride.
And become separated in solution. Notice that water molecules cluster about the anions with the
See, the orientation of the water is different, whether it's dissolving a positive or it's dissolving a negative.
With the positively charged cations through the lone pairs of electrons on the oxygen.
All right, there we go. So now the next part that we want to talk about is called cohesion, right? At the end of today's class, during class, we talk about something called hydrogen bond. Because water has this partial positive and negative feature, or water is polar, when two water molecules are close to each other, they can bond to each other. So what you can see right here, I have a water molecule right here. We have the oxygen and we have the two hydrogen. The hydrogen will have a partial, what is it? Partial positive, and oxygen will have the partial negative. But if you were to have another water molecule that also has the partial positive of the hydrogen, the white dots, and then the partial negative of the red dot, then they can attract to each other, right? So this interaction between two water molecules, this weak attraction is weak enough that you can pour water and you can break water apart, right? This attraction force between water molecules is called cohesion. So here we go. Cohesion is the ability of water to stick to itself. And it sticks to itself by forming hydrogen bonds with other water molecules. So you can imagine this. If you do a belly flop when you're jumping into a pool, it hurts, right? It hurts because it's hard to break those hydrogen bonds when there are so many hydrogen bonds together. It's easy to break some hydrogen bonds. You can pour water, you can drink water, everything is fine. But if your entire body is slamming into water, those hydrogen bonds actually create a lot of force, and it's hard to break that many hydrogen bonds at the same time, okay? So cohesion, think about co, is together. Cohesion is the water molecules attracted to each other and coming together. Next, so we have those hydrogen bonds. Next, we have something called adhesion. Adhesion is water sticking to other things. Because water is polar, again, it has the ability to stick to other things. So for example, water drops stick into the side of a beaker, or you see these water drops right here. This is adhesion, okay? We're going to move on. The next water property is called surface tension. So surface tension is a tension, right? Again, we're talking about something that's hard to break. Surface tension makes the surface of water hard to break. For example, some insects can spread out its body weight enough that it can even walk on water because they're not breaking the water apart. This is a result of cohesion, right? Water sticking to each other, they stick to each other. It's hard to break those hydrogen bonds, right? So next we have something called capillary action. So what you see right here, let's look at me first. So what you see right here, I have a water molecule, and I have water molecules in this cup, okay? And I can drag out more water molecule. The reason for that is because water molecules stick to each other, so when one water molecule is pulled up, other water molecules get pulled up with it, okay? So this is called capillary action. Capillary is a very thin tube of some sort. Capillary action allows water to travel upward against gravity. And this is what allows really tall trees to live, or any tall trees, or even bushes to live, because in order for those trees and bushes to live, they have to have water going all throughout the plant. And the water has to be able to travel against gravity. This water traveling through these small thin tubes within the vascular system of a plant is called capillary action. This is a result of both cohesion and adhesion, because as water is pulling each other up, right, it's as if, let's say you hold someone's hand and there's also an entire chain of people holding hands. When you pull one person, everybody else is going to come along, right? So that's cohesion doing its job. Adhesion is water sticking up to the wall of the capillary tube. The water is just going to keep on going up. Both cohesion and adhesion working together allows capillary action to happen. So next, this is something you know. Water in liquid form is less dense than solid. Density What is it? It's how tightly molecules are packed together, okay? So when you look right here, cold water, the molecules are packed more together. This is normal, right? You know that the lower part of the atmosphere is, well, just kidding, never mind. Well, in a room, let's say you have air conditioning. The lower part of the room will be colder, and the upper part of the room is going to be warmer. And think about hot air balloon. You're just heating up the air, and you're able to go up because the air is less packed, is less dense, and is able to allow you to float upward, right? So between cold water and warm water, cold water has molecules more densely packed, and warm water has it less densely packed. This is pretty normal. This happens to all the molecules. But between water and ice, this is something that doesn't happen as often. For ice, normally a solid, right? Think about solid brick of iron versus liquid iron, which you don't see on a daily basis, but the solid is very, very dense, right? It's very heavy, very dense. But when you look at ice, because water molecules form these hydrogen bonds, the ice has to orient itself in this way. The water molecules have to orient themselves in this way so that you can't put more space in between these water molecules. So here we go. Water is less dense as a solid than liquid. This is something you definitely need to know. And then that means that water expands when it's frozen, right? When you freeze a water bottle, it becomes, it's exploding a little bit, right? Or if you're freezing soda, for example, sometimes it explodes. Don't try that at home, please. But this is why ice floats, and this is really important because ice is floating on the top, and that allows fish to continue to live during winter. There's still enough water underneath it, and it's not even that cold, right? And the next one is called high specific heat. Water has high specific heat. What does that mean? Specific heat talks about how much energy it takes to heat up something. High specific heat means it takes a lot of energy to heat up something, right? So if you think about when you go to the beach over the summer, you go in June, the water is really cold, right? The reason for that, and it could be really hot outside, but the water is still really cold. Or if you went to the pool in the summer, right? In the morning, sometimes the water is really cold, even when it still is pretty warm outside. The reason for that is because it takes a lot of energy for water to heat up. But also, if it takes so much energy for water to heat up, it also takes a long time for water to cool down. So if you think about going to the pool maybe at night on a summer day, it might not be that hot outside anymore, but the water is still pretty warm because water can hold on to that heat. So here we go. It takes a lot of energy to heat water up than other substances because in order to heat up water, you have to break those bonds. When something is heated, those molecules have to move faster, and when water wants to move faster, it has to break those hydrogen bonds. And hydrogen bonds, although it's not as strong as ionic or covalent, is still kind of hard to break. This means water has a high specific heat, okay? Again, ice floats. We have ice floats. All right, the computer is not, well, ice floats, right? We know ice floats. These are all just things you need to know. Water is one of the only substances that expands when it freezes. Almost all other substances constrict when temperature drops. This occurs because of the polarity of the molecule, right? Water is polar. They have to arrange themselves a certain way. Ice is less dense than water. Here we go. Here's ice. Here's water. You can take a look at these true-false questions. Think about which one is right, which one is not. But otherwise, you can move on to doing a little practice on the Google forum. Have fun!